Good day. So, in the last lecture we had discussed about the cellular network and that end of wireless networking. Today we will talk more specifically about data networking and wireless LAN and maybe and wireless MAN and things like that. Actually, there has been an explosive interest in wireless technology in just the last few years, okay, and a number of different systems have come up. It is not known at this moment that what will finally stabilize, but a number of systems have come up, and some of them are on drawing board, some of them are on actual deployment. So, we will talk about just a few of them, the more important ones today. So, today we will talk about wireless networks. Now, and specifically if I say wireless LAN. So, what is the idea? It is just a LAN, that means just a local area network. Only thing is that without wires, which means that you do not have to wire up the whole place. You do not have to have a wire coming into your system. You can walk into a room with a laptop and you are already on the network. But this has some peculiar problems, so we will discuss them. So, it is not as easy since signals are of limited range. Unlike wired LAN, if A can hear B and B can hear C, it is not necessarily true that A can hear C. So, this is a problem which we will have to handle. So, we will see why. And secondly, in many of the cases, in most of the cases actually, these wireless LANs use unlicensed frequencies and low power. Okay. Low power is important because you want to have a small size cell, so that in another part of the building there may be another cell, just giving services to another group of users. Okay. As we know that this way, by doing space division multiplexing, we can increase the number of users who are on the network. So, one of the most important LAN standards today, wireless LAN standard, is 802.11, and there are various versions of 802.11, and the speed varies from 2 megabits per second to 54 megabits per second. We will also talk a little bit about Bluetooth, which is a personal area network. We will talk a little bit about wireless MAN, which is 802.16, and just mention a few other emerging technologies. There are two modes of operation in a LAN. Okay. In the presence of a control module or a CM, often called a base station, just as we have a base station in case of a mobile, similarly here we can have a base station which in 802.11 parlance is called an access point or AP. So, we can have a base station or a control module and a number of users. Okay, that is one mode of operation. The other mode of operation is a rather ad hoc network. That means, you just have some peers and there is a peer to peer connectivity and there is no central module. So, applications could be LAN extensions, cross building interconnect, nomadic access, that means somebody has just moved in, he can immediately have access, ad hoc networking and things like that. So, these are the two modes of operation. One we have a base station which is sort of controlling them. So, this is somewhat slightly easier to handle than a completely peer to peer ad hoc network. And actually what happens is this control module or this access point in the case of 802.11 could be connected to a wired network. So, that all those stations which are connected to the control module via wireless link, they get connected to the entire network. So, they may connect straight away to individual PCs, or they may connect to some network hub or switch, etc. They may connect to a server and they may connect to a number of LANs really. Okay. So, this is the picture of a single cell wireless LAN, single cell WLAN, and we can have multiple cells of WLAN. So, in each of the cells we will have a control module, and then which will serve some of the user modules. you may note that there may be a geographic, I mean there may be a region where it is possible to connect to either of the CMs. Okay. So, that is something that the user model will have to handle. Now, WLAN requirement. So, this is some kind of a wish list actually, alright. So, what all we would want from a wireless LAN. So, good use of bandwidth, that is we want high throughput, everybody does. Number of nodes, it should be large, maybe in the hundreds. Good connection to LAN backbone is required because nowadays just local network by itself is of limited utility, since everybody is getting used to be connected to the entire network, meaning the internet even all the time. So, the backbone connectivity is also important. Good service coverage, okay. I mean wherever I am, I would like to be connected. So, this will be good service coverage or range. Minimal battery power consumption, this is an important issue in any kind of mobile system, because if the battery consumption becomes high, either you have to carry heavier batteries or you have to charge them often. So, that is not good. So, we want minimal battery power consumption. Transmission security and robustness, this may be an issue in many cases because you know in a wireless system the medium is of course open to everybody, alright, including snoopers if any. So, but you would like your communication to remain somewhat private or protected, and in some cases that may even become crucial. So, we want security and robustness, okay, and some co-located network operation. License free operation, this is another important issue. For example, the ISM band. The ISM band consists of this industrial, scientific and medical. For them there is a band of frequencies which is free, there is no license on it. And why unlicensed operation, that means operation with the unlicensed band is important, is because then anybody can really, whoever has got a good idea and whoever can develop a good system can go ahead and compete in it, and that way the overall technology improves fast and people get cheaper and better quality service. So, that was important. So, ISM band is generally preferred, but it is not that we always in wireless networks we always stick to ISM band, but many of them do. Cell handoff and network roaming, this is another thing we would like to have, okay. This I mean as I said that this is some kind of a wish list, that it is not that all of them are achieved 100% today, okay, but these are the kinds of things we would like to have, like cell handoff and network roaming. Just as in voice network we can roam from one cell to another and our call remains online, similarly our network connection we would like them to remain online when we move from one cell to another. So, dynamic management, adaptive MAC address management, dynamic and automated addition, deletion, relocation of end systems without disruption. And then we want a choice of physical solution, for example, infrared, spread spectrum, narrowband, microwave, etc. As I said, so there are a number of standards came up. Here I am just showing some standards in the 802.11 family, then there is an 802.15 family, 802.16 and so on, okay. So, this is just one of them. So, 802.11 originally it was this 2.4 gigahertz ISM band and used FHSS, which is frequency hopping spread spectrum with 1 to 2 Mbps speed, or direct sequence spread spectrum DSSS 1 or 2 Mbps, and then slowly it sort of graduated, and then it fell over to 3 standards: 802.11b, which is the most earliest and the most common one. It was followed by 802.11a and 802.11g. So, these two are in the 2.4 gigahertz ISM band, whereas this one is in the 5 gigahertz ISM band. So, we will not go into the details of all these and what are exactly are the difference, etc. So, today what we are trying to do is that we are just trying to get a general idea, okay, because there are just too many standards. 802.11 LAN architecture is now by now we know that we will have an access point which is connected to a hub or a switch or a router, and this access point so this is in one cell, this is another cell. So cells may be called basic service set, also known as cell. In infrastructural mode, it contains wireless hosts. So these are the wireless hosts. It contains an access point. Okay. Of course, in an ad hoc mode, there will only be there will not be any access station. So they will all be connecting to each other in a peer-to-peer model. And so the physical layer in 802.11 family itself, you see that there are so many techniques are used. FHSS, which is frequency hopping spread spectrum, direct sequence spread spectrum, orthogonal frequency division multiplexing, OFDM, HRDA SSS, that is another one, OFDM, and so on. Above this we have the data link layer, that is that LLC and the MAC sub layer, and above that we have the upper layers. So we do not have the time to go into the details of the physical layer technologies, like how exactly the multiplexing and multiple access is done, but this is just a very broad and high level view of the system. So we have the input data which is encoded. So there is a channel encoder, it uses either FSK, that is frequency shift keying, or phase shift keying, FSK or PSK. I mean there are other variations of this. So we will just get to get a feel of this. So this fits into a modulator, and then there is a pseudo random pattern generator on the, this is on the sender side. Similarly, there is a pseudo random pattern generator on the receiver side, and these two are synchronized. So this modifies the main carrier, so and it then goes into the air or whatever the medium. Then it arrives at the other end, plus with some maybe noise also added to it, where it is demodulated and it is decoded, and we get the output data. Okay. Now, how do we, I mean just glossing over the physical layer, now how do we handle the multiple access and 802.11? It avoids collisions. That means it avoids collision. We know that when two or more nodes are transmitting at the same time, then their signals will collide and we will have a collision. So 802.11 tries to avoid collision. It does CSMA. CSMA, if you remember, is the carrier sense multiple access. So it does some carrier sensing. It senses the channel before transmitting. Of course, it does not collide with ongoing transmissions by other node. Okay, but it does not do any collision detection. Okay, and why? The reason why it does not do any collision detection is that if it has to do collision detection, first of all, what would happen is that not all traffic is sort of apparent to all the nodes in the network. We will show you a diagram that why this is not so. There are various reasons it could happen. So that is one reason that even if there is a collision, and even if you are doing collision detection, you may not be able to detect it at all. So that is why the stress here is not to do I mean collision detection like you do in a wired LAN like Ethernet, but to avoid the collision. All right. So it is difficult to receive or sense collision when transmitting due to weak received signal and fading, etc. And it can't sense all collisions in any case, hidden terminal, fading. So goal is to avoid collision. So this is called CSMA CA. Instead of CSMA CD, we have CSMA CA, that is CSMA with collision avoidance. So this is a diagram which shows you why what this problem about hidden terminal. For example, so you have A, B and C. Now B can sort of listen to C, A can listen to B, that means AB can communicate with each other, BC can communicate with each other, but between A and C there is some kind of an obstacle. So A and C cannot communicate with each other. Okay. Even if there is no obstacle like this, the situation could be something like this. Suppose this is A, this is B and this is C. Now at the point B, A and B have fairly high signal, whereas at C A's signal strength is very low, similarly at A C's signal strength is very low. Okay. So, some of the terminals may be hidden from some other terminals. So, this is a problem. So that is why our MAC protocol is sort of designed to handle situations like this. So, this is the MAC overview. We have a number of boxes here. So, and I will not go into all the detail like radio management, power management, management information base. This is for network management. There is an addressing, there is a security part like shared key and association management. Similarly, there is a fragmentation of large frames and so on. So, we will not look into all this. We are specifically we will just mention that for addressing we use this similar 48-bit MAC address which are Ethernet compliant. Okay. You remember that the Ethernet address or the hardware address or the MAC address that we talked about when we discussed Ethernet, that is a 6 byte or 48 bit address, and 48 is of course a very large address space. That means 2 to the power 48 is 256 trillion, which is a very large number. So, there is no shortage of addresses. So, a bunch of addresses may be given to these. So, the same kind of 48 bit addresses are used for this also. Okay. So, making it Ethernet compliant of course has its advantages, because Ethernet is the just other ubiquitous kind of network. Another point is that we have that acknowledgement request kind of system. That means where some frames and some fragments etc. they are acknowledged. So, if the acknowledgement does not come, we have retransmission. So, acknowledgement with retransmission and we have maybe you have some error correction also. And radio link security, data authentication, data encryption, simple scrambling or peer to peer etc. these may also be there. We will not be discussing this as we will not have time. And in the radio link there is a question of quality of service. There is this CSMA-CA. So, we will just look into this channel access mechanism in some more detail. And dedicated real time support systems are also there. So, they are with PCF. So, there are actually two mechanisms which may be simultaneously present in the same system, DCF and PCF. So, we will be talking about this. The standard provides two modes of operation which are DCF, which is mandatory. That means every 802.11 system has to be following DCF at least. So, it is a best effort service, uses CSMA-CA, and that is CSMA with collision avoidance. And there is another mode which may be optional, which is PCF. So, this is a base station. This is the point. So, this is a distributed control function and this is a point control function. This base station controls access to the medium, uses a polling mechanism with higher priority access to the medium. So, actually if PCF is there, what PCF can do is that actually PCF can take precedence over DCF and it can give some guaranteed kind of service or quality of service to some users. So, that is possible. There are three different types of frames: data frames, control frames and management frames. So, one is the point coordination function, which is PCF, the other is the distributed coordination function, which is the DCF. Okay. So, and how, I mean which one you are using, maybe you are not using PCF at all. So, that would be a network administrator's choice. So, if you are using PCF, that would give you some contention free service, whereas if you are using DCF, you are using a service where there may be contention. Of course, you can use PCF and DCF at the same time, all right. So, how does the protocol work? From the sender side, if it senses the channel idle for DIFS, which DIFS is a period of time which is defined, which can be configured, then it transmits the entire frame. So, it just cannot send something as soon as the channel is idle, it has to wait for at least DIFS amount of time, and it does not do any collision detection. Alright. So, how does it know that there will not be any collision? Just because you have waited for DIFS amount of time does not mean that there will not be any collision. There may still be any collision, because somebody else may also be listening to the channel waiting for DIFS amount of time and start transmitting, and you are not doing any collision detection. The point is that you will not get an acknowledgement, unlike the Ethernet system where there is no acknowledgement. Here this is an acknowledgement based system. So, you will get an acknowledgement. If you get the acknowledgement, you know that there is a collision, and if you do not get an acknowledgement, you know that there is a problem. So, you retransmit. So, if you sense, if on the other hand you sense the channel to be busy, then you do some and you start some random back of time, just similar to Ethernet, like you do binary exponential backup, etc. So, similar. So, you start random back of time, timer counts down while channel is idle, transmit when timer expires. If no acknowledgement, increase random back of interval and repeat 2. So, this is the system. So, if there is no acknowledgement, that means it has not succeeded. So, you increase the back of time and repeat. Okay. By the way, another reason why collision detection is not done in wireless network is that for many of the radio systems it is difficult to do transmission and reception at the same time. Alright. So, collision detection, that means you keep on doing collision detection while you are transmitting, that while you are transmitting you just keep on listening whether or not it is going through okay, or there is some garbled thing in the medium, but that is difficult to do in many systems. So, that is another reason why CD is not done. In the receiver, if it is simple, if it gets the frame okay, then it returns acknowledgement. After SIFS, that means this is another time interval which is sort of defined. So, after some time it will send the acknowledgement. So, ACK needed due to hidden terminal problem. So, there is a sender, there is the receiver, and suppose after DIFS amount of time the sender has sent some data, the receiver has received it. So, after SIFS amount of time it sends back the acknowledgement. There is another scheme which uses this RTS CTS exchange. So, what suppose A wants to communicate, this is the AP and this is the B. So, A wants to communicate and let us say B also wants to communicate. So, A sends a request for transmission. So, it just a reservation request it sends. B also sends a reservation request at the same time, there is a collision. So, since there is a collision, none of them will get it. Actually, how they get it? They will get it by some signal from the AP, as we will see. So, what happens after some time? So, A may be sending the request again and maybe it has gone through. So, once it goes through, the AP will issue a CTS that okay, now you can send CTS A, and this CTS A, please note that this not only reaches A, it also reaches B. And since now B knows that it has been reserved by A, B will back off or defer for a considerable period of time. So, B will defer for quite a bit of time, and A will send its data, then A will get its acknowledgement. Okay. This is an RTS CTS based scheme. So, this is another example. So, somebody A wants to send, so it sends an RTS, gets a CTS from B. So, A can now send the data. By the way, this RTS and CTS has been detected by C and D also. So, what they do is that now they know that somebody is communicating. So, this NAV or network allocation vector, so it automatically puts itself off. So, this is a very polite kind of system. So, it automatically puts itself off till it gets the acknowledgement. So, A wants to talk to B, C is in range of A, but D is not. However, D is in range of B. So, that is why the NAV of C starts here, whereas when B sends a CTS for meant for A, then D catches it and starts its own NAV. Okay. That means starts its own blocking time. So, this is called virtual channel sensing. Now, just to mention that how this point coordination function and distributed coordination function works at the same time, the PFC and DFC, and why we use this DIFS and SIFS, these two periods of time. So, there are actually 3 time intervals which are defined, which are configured actually. So, this is DIFS, this is PIFS, this is for point control function, and this is SIFS. So, please note that when the medium is busy, after that if somebody wants to send, he cannot send immediately, he has to wait for DIFS amount of time. Now, if PCF is also operating at the same time and PCF wants to send something, now PCF has to start doing that within this PIFS amount of time. So, somebody who wanted to send and is waiting for DIFS, when he gets this, when the PCF grabs the channel, then this other node, it will defer for a longer time, and there is an SIFS after which acknowledgements are sent. And after this, after the DIFS, there is a contention window where there may be a random backoff and the next frame is sent. So, this is the suppose this was the previous frame. So, within SIFS the control frame or next fragment may be sent here. So, either acknowledgement or control frame or next fragment is sent here. PCF frames may be sent here, that means after PIFS amount of time the PCF the point coordination function PCF will grab the channel, and if PCF has not done that, then after DIFS amount of time there can be a distributed, that means anybody can try to send anything, alright. And there is another time which is called EIFS for bad frame recovery. Okay. So, SIFS is for short interframe spacing, PIFS is for PCF interframe spacing, DIFS is for DCF interframe spacing, and EIFS for extended interface spacing. So, these are the different kind of spacing. So, this way this PCF and DCF can work at the same time. Okay. Another point is that if you have a very large frame, there may be a problem in the sense that I mean, if a large frame becomes garbled, then it so a large frame has a larger sort of window where it puts off everybody. So, for better throughput, it may be a good thing to break up a large frame into smaller fragments. Okay. So, after an RTS CTS, so it may send us one small fragment, then acknowledgement fragment, to an acknowledgement, and so on. Okay. And the other thing is that a large frame is more likely to beget errors. Okay. And if you just do the calculation, you will find that if you break it up, there may be orders of magnitude difference between the error probability of a large frame and a smaller frame. All right. So, overall your throughput may be much better, and especially in noisy situation your throughput may be much better if you send smaller fragments. If you smaller fragments, first of all you can do some error handling etc. locally, and you can handle it, that is one thing, and secondly for a large frame the probability of error is much higher. Okay. So, just a little bit about the 802.11 frame addressing. If you remember that in a Ethernet we had two addresses, the source address and the destination address. Okay. Here actually very surprisingly we have 4 addresses, alright, and just to show you why. Address 1 is the MAC address of wireless host or AP to receive this frame. So, this is the destination, immediate wireless destination, okay, the wherever you want to land up on this wireless link.
Address 2 is the MAC address or wireless host or AP transmitting this frame. So, this is the source address, so to say. Now, the point is that after all, quite often what you would want to do is that you are not really interested in all this technology business which is going on for this wireless transmission. You are trying to connect to a network which is in the outside world. So, this what will happen is that this access point will connect to a router. Now, or it may connect to a LAN and that LAN may be connected to a router. So, basically what you have to do is that you have to for going out of this network altogether, and that means not only this wireless part of the LAN or the WAN part of the LAN, but to get out you will have to go to the router. That means you will have to know the MAC address of that particular port of the router which you want to sort of reach as a next stop. Then the router will decide where to go next. So, the MAC address of that router, that also must come from the source itself. So, address 3 is for that MAC address of router interface to which AP is attached, and AP may be attached to a LAN and it may have multiple address possibilities there. Address 4 is used only in ad hoc mode, so we will not discuss it there. So, these are the 4 addresses. There are some more this thing we will see, and this is the payload, okay, and the payload is from say 0 to 2k bytes. So, these are all in bytes. So, 6 bytes. So, these are all MAC addresses. So, 6 byte MAC address. So, 18 bytes just for this address and 4 addresses 24 bytes there, okay. So, this is the picture. So, originally we had just the router's MAC address and AP MAC address. So, these two destination and source address, and when you are sending from a wireless host, what you have to do, the AP MAC address, the host MAC address, the router MAC address, these are the address 1, address 2 and address 3, alright. Just about the other fields, there is a duration of reserved transmission time. This is that in the RTS CTS system that we were talking that we showed you. So, there is a duration of reserved time. Then there is a sequence control, okay, for reliable. So, this is the frame sequence number for reliable ARQ. So, since you are doing acknowledgement with retransmission request, you require some sequence number for that window. So, we have discussed this. So, you have a sequence control number over here, okay. Then of course, there are other fields. It could be like type, like frame type, it could be RTS type, CTS type, acknowledgement data, etc., subtype. So, we need not go into all of these. And then just a little bit about the mobility within this of the thing, because whenever we are in wireless we will want to be mobile. Now, if we are going from one from under one AP to under another AP, that means from one BSS to another BSS, that is the basic service set, that is from one cell to another. So, what the mobile host will do is that it will sort of sense whoever is stronger and he will connect there. So, there is some chance of confusion in this thing, but since he sort of handles it and it is not so maybe he will just as he moves he will connect from AP1 to AP2, okay. But this is assuming that these two APs are in the same network, okay. If these two APs are in different networks, then the situation is a little bit more difficult and we cannot handle it at this layer directly. So, we have to go above this. Okay, so having quickly covered 802.11, which is the most common kind of wireless LAN that we see today. In many places we have 802.11 areas. Actually, in some places they are also called hotspots. That means, in a hotspot means this is under some AP. So that if a person is in that hotspot, he can connect to the network, and there are some campuses at least or some places where a large number of APs have been deployed, so that you are continuously, wherever you are in that whole campus, you are always in the network, alright. So, that is one kind of system, that is 802.11. So, we will see about so its range. Next we come to another kind of wireless systems, namely wireless MAN, that means wireless metropolitan area network. Now we want to what we want to do is that we want to connect an entire metropolis with this. Now obviously this 802.11 now is no longer sufficient. Okay. First of all, I mean the power actually 802.11, in order to handle more number of users we keep the power low, so that we have smaller size cells, etc. But in this metropolitan area network there will be many users in the same cell, alright. So working in that 2.4 gigahertz ISM band, that will not be sufficient anymore. So we have to go for a much wider range of frequencies, and for this we need to go to a higher frequency in the so called millimeter wave region. Millimeter wave means the wavelength is of the millimeter order. Okay. So there is a standard for this wireless MAN, it is called 802.16. Okay. So what you might do is that you might have a large tower, because these millimeter waves usually travel in straight lines. So what you have to do is that you have to have a line of sight to the base station. So there is a line of sight, so you have to have a large tower so that everybody can be on the line of sight. Okay. And these different base stations of course may be connected through a WAD network, or this base station would be connected to the general network through a maybe some fiber optic line or something. So this is the 802.16 protocol stack. This is orthogonal phase shift keying or quadrature amplitude modulation, QM16 or QM64. So these are the different kinds of modulation techniques which are used. We are not going into this. There is a transmission convergence sublayer, that means how to handle it from here. Again, once again we do not bother about this. We will just talk a little bit about the MAC sublayer common part and the service specific convergence layer. So we will just talk a little bit about it. As I said that there are so many systems are coming up these days, it will not be possible to handle all of them. Okay. So this is just the frame format. So there may be a data frame and the control frame, that is the, in the control frame is the bandwidth request frame. Now there is a connection ID, this binds the endpoints to the system. So there is a connection ID through which any particular system would get a chance to communicate. Bits, the first bit defines if it is a data or a control frame. So if it is a data frame, the first bit is 0, if it is a control frame, the first bit is 1. Then it says whether the payload is encrypted or not, so EC is 1 or 0. Type is the type of the frame, there are management frames and things like that. So C1 is the checksum. So there is a checksum indication key is used and so on. So we, once again we need not go into all the details, but so it uses CRC error correction. So header, this is the header portion, for the header portion there is a CRC and the data connection ID, etc. So basically the access to the medium is controlled through this connection ID. There are different service classes which are defined in this. One is the constant bitrate service for voice, real time variable bitrate service. So this is a VBR, so RT VBR this is called, or non real time variable bitrate service, that means NRT VBR, which is for high quality data, and for ordinary data, email, HTTP, etc. this is a best effort service. So from a constant bitrate service, and so there are different service classes are possible in 802.16, and all these are possible because here the MAC is simply controlled by the base station. Alright. The key architectural principle is traffic control by the base station. So the base station controls the traffic totally. It creates frames of time slots and allocates time slots to connection IDs. So time slots are allocated by service class. This means that if there is a constant bitrate service, what the this thing will what the
base station would do is that in every frame it is going to allot one or more slots to this constant bit rate service, okay, so that it gets a constant rate of bits, all right. So similarly, so it will depending on and if it is that whoever reserved that constant bit or requested that constant bit rate service, if he is not using it at any particular point of time, then it is going empty. So that is why he has to pay higher for this constant bit rate service. Similarly, there are variable bit rate service, and finally, with real time, which has a slightly higher priority than the non real time one, and of course just the available bit rate service, that whatever else is left, that may be given to those connection IDs which are only getting an available bit rate service. So these are the just a picture showing frames, and each of the frames will have some slot. There are some guard times between the frames. Some of the slots are reserved for upstream traffic, whereas some of the frames are some of the other slots are for the downstream traffic. Quite often what happens is in these metropolitan area networks, or in many networks actually, the downstream traffic tends to be much higher than the upstream traffic, and we all know, for example, if you are surfing the net, which is a very popular activity, you just send one request, which is a very small thing, and in response to your HTTP request, a large page with a lot of graphics etc. may be downloaded. So the downstream traffic tends to be much larger. So there is a lot of asymmetry here. So that is why a few upstream slots and a lot of downstream slots. So frames and time slots are for time division multiplexing or duplexing. Actually this time division duplexing, because both upstream traffic and downstream traffics are given some slots. Duplexing means that is going in both direction. Base station allocates time slots in frames to connections. So there are some connection IDs, and to a particular connection ID, the base station may allocate time slots. CBR, as I said, constant bit rate services highest priority. RTVBR, that means real time variable bit rate, next highest priority. NRTVBR is the third highest priority, which can be delayed, and anything remaining is the best effort contention based access of unallocated time slots to other kind of traffic. So this is how it is done. Next we move on to another end of the spectrum. So first we talked about wireless LANs, alright, that means 802.11, and as I mentioned that has a lot of variations like 802.11 A, B, G, etc. Okay. So there is 802.11, that is the LAN side. Then we talked about MAN, metropolitan area network, and now we are going to the other end of the scale, which means that a very small networks, let us say personal area network, that means just a network between what I have in this pocket and this pocket and my in my hand maybe, so a very small area and maybe just in front of me on the table. So it is a very small area kind of network, and this is a so we will talk about one thing which is quite popular, namely Bluetooth, which is 802.15.1. So 802.15 is for the personal area network group, 802.11 is for local area network, 0.16 is for metropolitan area network, and 0.15 is for personal area network. So this is less than 10 meter in diameter. So you see that this is very small. Replacement for cables, mouse, keyboard, headphones, etc. So whatever I may be using, so this may be replaced all by wireless links. That was the idea. This is ad hoc, that means there is no infrastructure is necessary. This works with the idea of master slaves, that means slaves request permission to send to master and master grants request. So in any such cell or a radius of coverage, there will be a master and then there will be some slaves. Okay. So M is the master device, S is the slave devices, and P are the park devices, that means which could this thing, but which are sort of inactive at the moment. So they are called park devices in Bluetooth. So Bluetooth characteristics, I mean Bluetooth and 802.15 they are almost the same. There are some small differences, but it is not very important. So it operates in the 2.4 gigahertz industrial scientific, that is ISM band, and which is unlicensed.
packet switched, okay, 1 milliwatt, okay. So you see, so this is then a very important issue, that this uses very small amount of power as opposed to, let us say, 500 milliwatt for a cell phone, okay. This is low cost, that means up to 10 meter to 100 meter range, and uses frequency hop spread spectrum. So FHSS is used, we will see what kind of FHSS, which divides the frequency band into a number of hop channels. During connection, devices hop from one channel to another 1600 times per second. So you see, it is sort of hopping the frequencies very fast, okay. So that is one good thing, because if some part of the frequency band has a noise, so it has got better noise immunity, because it is hopping such a large number of times. So there are a large number of channels. Why a large number of channels? We are talking about a personal area network, but nowadays I may be using so many different gadgets, etc. I mean, when I am using my, let us say, PC, my I may be having a cell phone, I may be having a laptop, I may also have a desktop in front of me. Each of them will have a mouse, and all these peripherals, let us say that it has a monitor, and all these peripherals may be connected in some way through wireless, alright. So there may be so many things. So altogether about 79 channels are possible in Bluetooth, and so they go on hopping in the frequency. So bandwidth is 1 to 2 megabits per second. We are not looking for a very large bandwidth over here, because this is just more for control and function rather than downloading files. Supports up to 8 devices in a piconet, okay. Now what is a piconet? 2 or more Bluetooth units sharing a channel, that is called a piconet. It has got some built-in security, non-line of sight transmission through valves and briefcases, because of the frequency band which it uses integration of TCP/IP for networking. So piconet is a small area network, alright. So it is ad hoc, which means that network, that means no predefined structure. So there is no predefined structure, based on available nodes and their locations, formed and changed in real time. As you can see that these networks are being formed and being changed in real time, alright. So they may be changing all the time. So basic connectivity is point to point, that means from the master to the slave. Piconet is point to multi-point master, multiple slaves. 2 or more piconets can be connected to form a scatter net. By the way, I mean, how does a piconet start? Okay, anybody can start it and claim himself to be a master, and the other devices which are coming in later will become the slaves. So anybody can start and become a master, alright. And so this is one piconet, this is another piconet, and they may be connected, and for the 2 piconets may be connected into a scatter net. If you want to have a scatter net, then you have to have a bridge from this piconet to this other piconet, alright. So you have a bridge slave. So 802.15 version of the Bluetooth protocol architecture, as I said that these two are slightly different, but we will not bother about it. We have the application profiles, then you have the physical radio, baseband, the link manager. By here the link manager means the radio link manager, and then there is a middle layer, which is the service discovery, telephony, RF communication, and so on. So we will, once again, we do not have the time to go into the details of this. The idea is that I mean, you can switch from one kind of service to another kind of service depending on the context and situation. So that is this thing. This is a more detailed this thing of the different kinds of protocol. Let us skip this also. In the physical layer, it has 79 channels, each 1 megahertz, using frequency shift keying with 1 bit per symbol. That is so it comes out to be about 1 Mbps per channel. Much of the, of course, this 1 Mbps the individual devices finally do not get a 1 Mbps throughput for the payload part, because the efficiency is quite low. Much of the 1 Mbps is taken up with protocol overheads caused by the frequency hopping. So this takes about 250 to 260 microsecond needed to stabilize radio after the hop. So, this leaves about 366 bits for actual data, of which 126 bits are headers. So, leaving only 240 bits for data per slot. So, what was supposed to be 1000 bits has become 240 bits. Okay. But for small devices which are getting locally connected to each other, even 240 bits per second kind of speed may be more than enough. Okay. But there are so many different channels are possible, 79 channels are possible. So, this is just a little bit about the Bluetooth frame structure. We have the access code and then a header and then the data, and the header will contain the address, type, etc., and some flags and some checksum. So, it is an 18 bit header is repeated 3 times for a total of 54 bits. Okay. So, access code is identifies the master to its slaves, one master and up to 7 active slaves, some slaves in parked mode. Okay. So, these are the system block. We have a Bluetooth radio and a Bluetooth link controller and a Bluetooth link manager. So, 2 physical link types have been defined. One is synchronous connection oriented link between the master and a single slave for audio and data, or asynchronous connectionless ACL link, point to multi-point link between the master and all the slaves on the Piconet for data only. So, this is for data and is used for this thing, other this thing. So, if some voice channel is there, you can get a synchronous connection oriented link, so that you get a fair or acceptable quality of service. So, multiple access scheme is based on FHCDMA, that is frequency hopping CDMA, high speed of hops, and cold division multiple access offers the best properties for ad hoc radio systems. So, as I said, 79 hop carriers have been defined at a 1 megahertz spacing. Now, the Bluetooth has been designed to allow a large number of independent channels, each channel serving only a limited number of participants. Theoretically, the spectrum with 79 carriers can support 79 megabits per second, but as we have seen that the efficiency may be something of the order of 25%. So, it will be much less than that. Different channels have different masters and therefore, also different hopping sequences and phases. Okay. By definition, the unit that establishes the Piconet becomes the master. As I said that anybody can start a Piconet and become its master. In Bluetooth, the master implements centralized control. Once again, we do not do any kind of try to do any distributed control. It is a small system. So, we do a centralized control by the master. Only communication between the master and one or more slaves is possible. Okay, which means that the slaves do not communicate with each other directly. Okay, it has to go through via the master. Master unit schedules the traffic in both the uplink and the downlink. There are various types of error correction which are possible, includes both FEC and packet retransmission schemes. At the baseband level, Bluetooth makers use of 3 types of error correction schemes: 1/3 rate FEC, sending 3 copies of each bit with a majority logic, 2/3 rate FEC from some kind of Hamming code, or automatic repeat request ARQ. So, this is the error correction scheme that is used. Just now we have talked about 3 different ends of the spectrum. So, I will just mention 1 or 2 more just to show you that there are all kinds of other possibility. For example, after this Bluetooth they became somewhat popular, etc., then there was a group who said that why not we make the make the radius of operation of this even smaller, but here the main emphasis would be on long battery life. Okay. So, that you put a small battery in a small device, it will just work till the battery's shelf life is over. So, it will be a very low power kind of thing. So, there was another group. So, we have this 802.15.4. Similarly, there is an 802.15.2 and 802.15.3. We are not covering any of them. This is just to give you a feeling of the kinds of things which are going on. So, 802.15.4 is a simple packet data protocol for low rate, no quality of service wireless personal area network for low power, low cost devices. So, low power and low cost, these are the most important things. So, naturally you will get low rate also, but for this kind of for many applications this may be quite fine. So, channel access is via carrier sense multiple access with collision avoidance and optional time slotting. Message acknowledgement and an optional beacon structure. Beacon means a signal which may be sent centrally to synchronize the systems. So, 3 bands have been and 27 channels are specified, 2.4 gigahertz and 16 channels there, 868.3 megahertz and so on. Okay. Sorry. It works well for long battery life, selectable latency for controllers, sensors, remote monitoring and portable electronics. Okay. So, for example, things like a sensor, all right. So, sensor just stays there, so it is supposed to do its work which is sensing and maybe send little bits of data from time to time. So, it is a low rate, no quality of service guarantee etc. is required, but a low power and low cost is very important. So, that is the focus of this particular group. So, configured for maximum battery life has the potential to last as long as the shelf life of most batteries. So, MAC uses 64 bit IEEE or 16 bit short addresses using local addressing. That means, if it is just locally, you can have your own 16 bit or you can use the full 64 bit IEEE address, simple frame structure, reliable delivery of data etc. So, as I said that there are two channel access mechanism. One is the non-beacon type, where it uses standard Aloha with CSMA CA, that is collision avoidance and positive acknowledgement. Or we can have a beacon enabled network where it is sort of synchronized. So, super frame structure for dedicated bandwidth and low latency, set up by network coordinator to transmit beacons at predetermined intervals. Just to compare quickly, between 802.15.4 which is the low rate and low power one and 15.1 which is the standard Bluetooth. So, smaller packets over large network, larger packets over small network, mostly static networks with many infrequently used devices. This is ad hoc networks, more dynamic. You can do things like file transfer here which you do not look forward to doing here. This is maybe used for home automation, toys, remote control, sensing etc. This may be used for screen graphics, pictures, hands free etc. So, this is a somewhat different niche of application which the two groups are this thing, but both are used wireless with different emphasis. So, as I said, there are many standards, I just listed some of them, there are many more which I have not put over here. 802.11b which is gives 11 Mbps, A which is gives 54 Mbps, G which is 54 Mbps, but it is backward compatible with B, because B was the one which was most widely deployed in the beginning. 802.16 in the that is for MAN. Bluetooth is about 30 feet radius. GSM, GPRS we have talked about when we talked about cell phones, which is got a 3G. People also talk about a 4G, but nobody knows even when 3G will actually get widely deployed. UWB we just shown, and then there are so many so many. The one last point, that if you have a wireless LAN, you would like to want to have a bridge, okay, for sort of connecting the TCP/IP stack etc. We will talk about TCP/IP later on from one to the other. So, we require a bridge in between. So, this bridging, so this WLAN may be a plain wireless LAN extension, and the application will sit on top of this. Okay. So, we want to require a seamless support for this bridge, that is very important. There are a large number of such protocols, because there is a lot of interest over there. Some of these protocols etc. will die off, some of them will naturally become very widely used, and this is one of the most important areas of networking today. Thank you.